All right, if you would grab out your box and whisker plot little packet here, hopefully this should be a quick refresher, but let's go through just a few examples here. All right, so box plots are useful for showing the distribution of values in a data set. A box plot is constructed from the 5-number summary of the data, which includes my minimum, my upper, or let's say lower quartile, let's see. Yeah, okay. Upper quartile, the median. I'm checking my spelling. The median, my upper quartile, and then my maximum. Okay, this one here is usually shown as Q1, and this one here is shown as Q3. Label the box plot below to show how the 5-number summary corresponds to the features in the box plot. Well, this right here is my minimum. That is the lowest number I have. This right here is my maximum, the highest number I have. Inside of my box, the middle line here is my median. The upper line in my box is my Q3, my quartile 3 or upper quartile. And my lower line in my box is my quartile 1 or lower quartile. Okay. The 5-number summary divides a data distribution into 4 parts. About what percent of the data values fall into each of the following intervals. Okay. Well, from here to here is 25%. From here to here is 25%. Here to here is 25, and Q3 to maximum is 25%. So each part is 25%. Well, anything that's before the median, so the middle to quartile 1, that's 25. Quartile 1 to median, that's another 25. So a total of 50%. After the median, well, it's to Q3 and then to the maximum, that's 50%. Anything in the box, well, Q1 to median is 25, median to Q3 is 25, so that is an additional 50%. Before the upper quartile, so before Q3, so minimum to Q1 is 25, Q1 to median is 25, median to Q3 is 25, so I have 75%. After the upper quartile, which is Q3 to maximum, it's just one section at 25%. Below the lower quartile, so Q1 to minimum, that is 25%. After the upper quartile, well, Q1 to median, median to Q3, Q3 to maximum, that is 75%. Between the median and the upper quartile, well, median and Q3, that is 25%. And between the median and the lower quartile, well, median and lower, that's another 25%. Okay. All right, let's look at some practice here. So a group of fishermen made the list of weight in pounds of the 19 fish that they caught last weekend. And I am asked to create my 5-number summary and my box plot. Well, I want to start by putting all of my numbers in order from least to greatest. Well, I have 1, 3. I have 1, 2, 3 4s. 1, 2, 3. 1, 2, 2 5s, 1, 2, 3, 4 6s. Let's see how many 7s I have. 1, 2, 3, 4. 2, 3, 4. 1 8, 2 8s, 3 8s. 1, 2, 3. I have 1 9 and I have 1 18. Okay. Well, my minimum, my lowest number is 3. My maximum, the highest number is 18. Okay. And then to find the median, now I probably do this a little different than most of you. If you know that there's 19, you know that you're going to cross off 8 each individual time. But I like to make sure that I'm double sure. So I cross off everything from big to small or small to big. Okay, I cross off the same amount until I get to the very middle, which my median is 6. Okay. Now define the LQ and UQ, or my lower and upper. I'm going to draw a line straight through my median, and then I'm going to find the middle number in between each section. So I'm going to find the middle number between here, and I do not include the median number. So it's everything else that's not included. So it looks like my lower quartile is 5. And then I'm going to do the same thing on the other side for my upper quartile. Mark off every other, well, everyone from upper to lower. And I notice that my upper quartile is 8. Okay, so to create my box and whisker plot, I'm going to start off by numbering my lines. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Well, I'm going to have a line at 3, a line at 18, because that's my minimum and maximum. My lower quartile is 5. My median is 6, and my upper quartile is 8. Well, 5, 6, and 8, create my box, and then 3 and 18 are considered my whiskers. Okay. All right, let's look at number 2. Your stud was practicing for the big track meet and made the list of times he was running his 100-meter, I'm guessing, dash. I need to create a box and whisker plot here. Now let's see. Looks like 11 is my lowest number. So I have 11. I'm going to have 12. So 1, 2, 3 12s. Then I have 13 at 1, 2, 3 13s. How many 14s? 1, 2, 1 15, 2 15s, 1 16, looks like 1 17, and 1 18. All right, well, my minimum is 11. My maximum is 18. Okay, get my pencil here. Let's see if we can find our median. So 11, 18, 17, 12, 16, 12, 15, 12, 15, 13, 14. Well, look here. So it looks like I have an even number of sets. So I come down to 13 and 14. Well, to find the median, I need to find exactly in between 13 and 14. So I'm going to do 13 plus 14, 4, 5, 6, 7, 27. And then I'm going to divide this by 2. Okay, so when you have an even number, you're going to divide it by 2. So 27 on the outside, 2 on the inside, or 2 on the outside, 27 on the inside. Well, 2 can go into 2 one time. 7, 2 can go into 7 3 times. At 6, I have 1. Well, add my decimal, bring down my 0. 2 can go into 10 5 times with nothing left over. So my median is 13.5. Now, we could have easily seen that between 13 and 14, the exact number between is 13.5. But if you had 2 different numbers that were further apart, then you would need to complete these following steps. By add the 2 numbers together, then divide by 2 to get here. Now, to find my upper and lower quartile, I'm going to take my median and I'm going to split the 2 numbers in half. And I'm going to include this number for the lower and this number for the upper. And so we're going to find our lower quartile here. Boom, boom. And it looks like that number is to be 12. And then let's find our upper quartile. Boom, 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 at 15. Okay, so I need to go to 11 to 18. So let's do 11, 11.5, 12, 12.5, 13, 13.5, 14, 14.5, 15, 15.5, 16, 16.5, 17, 17.5, 18, 18.5. Now you're wondering, well, why did you keep counting up by 5s? When you start by counting up by 5s, you have to continue counting up by 5s. Well, my minimum is at 11. My lower quartile is at 12, so we can go ahead and create that whisker. My median is at 13.5. Well, that starts my box here. My upper quartile is 15. That continues my box. And it looks like my maximum is at 18, which is my highest whisker. Okay. All right, so why does the representation, the box and whiskers for each of the 4 quartiles have different lengths if they each represent an equal number of data values? Okay, most of the time it could just be on your spacing. So it could be on your spacing. Another reason could be an outlier. Okay, as you notice up here where all of our numbers were between 3 and 9, but then we get one random pound up here at 18. Versus if we looked at the box and whiskers, we really have a long whisker. But here, if we look at this data set here, I go from 11 all the way up to 18. And I have just at least one halfway point, but it looks like each section is a little bit, more spread out to where you have different spacing. So each represent 4 quartiles. And so each of the 4 quartiles, they represent 25% of my data. Because if you think about it, to get exactly in the median is halfway. So I'll write this down. Median is exactly half, which is equal to 50%. Well, lower quartile is between minimum and median, which that is 25% of the way. And then upper quartile to, or minimum to upper quartile, define the upper quartile, it's from minimum to maximum, which is another 25%. So that's why each section is 25% of the data, okay? Because you have here at the beginning, then you have here at 50. Well, to get here, you have to go back to 25, okay? And then from here to here, okay, you got the end at 100. And then from here to here, you have to find the middle again, which gets you another 25%. So you have 0, 25, 50, 75, 100%, which includes your entire data. Okay, there's that for you guys. All right. And then on the last page, so many people consider both quality and price when deciding which products to buy. The box plots at the right show the distributions of pre-serving prices for natural peanut butters and regular peanut butters. Okay, so I've got 2 different box and whisker plots here. Calculate the 5-number summary for the prices of the regular peanut brands. So regular. So it looks like I'm going up here by 5s. Okay. And it looks like it's not going to be exact, but we can get really super close. So I'm going to extend these lines here to make it just a little bit easier. So it looks like my lower quartile, my minimum is at 8. Or sorry, my minimum's at 8. It looks like my lower quartile is probably at 14. My median is probably at 17. My upper, it looks to be at 21. And my maximum looks to be at, well, it's between 20 and 25 would be what? 21, 22, 23, 24, 25, 21, 22. So what, 22.5 would be for my regular. Okay. All right. Okay, so calculate the 5-number summary for the prices of the natural peanut butter. So let's look at our natural here. I can switch over to, a different color. Well, it looks like my minimum for that different color starts at my upper quartile, which we're going to say is 21. And then my quartile 1, if I can draw straight down, it's probably at 26, 25. So I'm going to say 25. Okay. Let's see here. Oh, interesting. It also shows a double line. So what I ended up doing is overstepping the median. My upper quartile is this one right here, which is above 30. So let's say like what, 32. And then my maximum here would probably be at 33. Okay. My maximum will be close to 33. Now, these are just really good educated guesses for you guys. But let's take a look down here. Peanut butter quality ratings. Suppose quality is the only factor buyers consider. Is natural peanut butter or regular peanut butter a better choice? Okay, so if we look at a quality rating of 0 to 100, where 100% is being the best one, we can consider this, is the natural peanut butter or regular peanut butter a better choice? And it looks like, based on our quality ratings, where most of our data is 50% of our data is here, it is between 55 and like 65, that our natural is the better data. All right, and then number 7, in a box plot, the length of the box represents the difference between the upper and the lower quartiles. The difference is called the interquartile range, or my IQR. What is the IQR for the quality ratings for natural peanut butter? So for natural, I'm going to take my upper and I'm going to subtract my lower. Okay, so let's say that the upper is like what? So upper quartile is what, 68, where lower quartile is what, 56, I think, 56. I mean, I'm just trying to get a good range here. So 68 minus 56, well, 8 minus 6 is 2, 6 minus 5 is 1. So my IQR is 12. Well, let's look at it for regular peanut butter. Well, regular peanut butter is right here. And it goes over to, it looks 30. We're going to say about 30. Okay, maybe 32. So let's say upper quartile is at what, 53, because it's not halfway. Lower quartile, I think we said it was at 30. So 53 minus 30. Well, 3 minus 0 is 3. 5 minus 3 is 2. So my IQR for this one is 23. Okay. If you have any questions, please let me know.